So, welcome to Controlling Your Neighborhood's Lights, or maybe we should call it Controlling Your Neighborhood's Habits. Of course, there is a big difference between the habits and the lights, because I'm not controlling the lights, but the habits of the users. You will understand that. My name is André Garrido, and this presentation is based on the master thesis of my Master in Information Security in University of Lisbon. There are 4 areas here in this presentation. I have the motivation, where I explain the whys. I have the ZigBee, and I will explain the ZigBee, the standard, because the project is based on the ZigBee. And I explain some attacks that I did, most of them without success, I must say. Other ones more interesting, and you will see. Why did I choose this theme? For me, it was obvious from day one that I need to choose something related with IoT. When I arrived at the master, since the beginning, I knew that I wanted to attack something that can have some impact in our daily basis. And I started searching for what can I attack. The first thing was a smart goggles for skiing, and my objective was to make a skier goes down a hill and probably kill himself. But I thought, okay, this is too much expensive, and I can't do this way. So I started looking for other projects, and I found some electrical plug system, smart system, that a user can turn on and off with the mobile or with a web portal. And it's very simple. I will explain a little bit more detail later. But the thing about IoT is that, as we know, the most optimistic statistics say that there will be 20 billion devices connected to internet. And this brings two major concerns, two major problems, is that, first of all, if we already have some problems with distributed denial of service nowadays, when we have this kind of numbers, of course, we will have a lot more problems, and will be way difficult to stop this. And the other thing is that nowadays, most of the IoT gadgets have personal information. And for me, it was like a personal vendetta. I think we need to save the personal information. For example, if you have a running bracelet, it might save in some database, a remote database, but it might save your weight, your height, your age, your running pace, your heart rate. And this could be somehow dangerous to us in the future. The case study was based on this, let's say, layer. I call it ZigBee layer. It's normal plugs, like the usual plugs that you buy on the Chinese stores. The main difference is that it has an on-off button that you can turn physically on or off the plug. These are the cases of these plugs. The main difference between this one and this one is that you have an infrared remote transmitter that sends signals to air conditioners to turn it on or off. You set it on the web portal, and you say, my air conditioner is a Samsung something blah blah blah, and then you from your mobile phone you say turn it on or off. It's good. In the web portal, you can even schedule your tasks. For example, if you arrive at 6 p.m. at your house, you can schedule for 5 p.m. To your heater, for example, and you arrive and the house is warmer. There are other two, let's call plugs, although they are not really plugs, but we have the meter. It's a programmable logical controller that is used for irrigation systems or water pumps, and we have a switch that is used for boilers and heat pumps. I only had access to these 3, and it was enough for doing my research, and this one. This one is like it's called ZigBee box. In reality, it's a router, a normal router, and make an IP connection between internet router and ZigBee box. Of course, there are some connections to the enterprise servers that control and send some actions to my plugs, so this can work in some way. My objectives with this master thesis were 2. For the fun part, it was the intrusion tests. where I can do some black box intrusion tests. The only info that I can gather, it was from flyers, from websites, from technical information, from books and manuals. I can use any attack vector, but I need to have cautious with ethics. I can, for me, it wasn't very good to attack some production server and gather some information from there and somehow exploit it. So I decided I only will work on my network, on my ZigBee layer, and I will focus on that. The other thing is to gather much information about tools and vulnerabilities about ZigBee. Since it's a protocol, it's not very seen in Europe, especially. In the United States, it's way bigger, but in Europe, it's not very usual to see. So what's ZigBee? Some people say that ZigBee is a protocol. In reality, in my opinion, it's a protocol. But some people say that it doesn't because it's based on 802.15.4. It's a specification used for wireless communication, like Wi-Fi. It's very similar to Wi-Fi somehow. There are three main characteristics. It has low consumption. You can have some sensors or some ZigBee equipments that last for 5 years in a warehouse, mainly because there are a low bandwidth that transfers all the data not very slowly, but very few data, and of course this goes to the low consumption. It's a characteristic low cost. The chips, usually from Texas Instruments, are very cheap, and this of course brings the devices cheaper than others. There are some persons too that say that ZigBee do create personal area networks. In my opinion, and this is my and some other people's opinions, is that it's a home area networks, because I will just go to 3 slides. This kind of plugs, for example, are routers. They can route data to other plugs, and so you can have a way bigger network than a personal area network. Usually personal area network is the Bluetooth. So I think we should make some difference between. And we can use dedicated profiles for home automation, smart energy, healthcare, green power. There are a lot more. You have special profiles. If, for example, you use gadgets or IoT devices for medical stuff, you will use the healthcare dedicated profile. This makes sense because it's a lot smaller and the chips doesn't have too much memory, and it makes some sense. The other thing is that ZigBee, and this could be a problem for me during the work, is that it works in regional frequencies. For example, in United States, in North America, North and South of America, there are 10 different channels for ZigBee. Strangely, in Europe, there is only one, the channel 0. In China, there are 4, and in Japan and Australia, there are 1. There are others, but these are the most important. But luckily, there is also international frequency that is like Wi-Fi. It's the same as Wi-Fi, 2.4 gigahertz. In the vendor's perspective, this is very useful because if you can sell worldwide, it's way better than selling only to the United States, only to Brazil, for example, only to Europe, Japan, and so on. And this was my first problem, is to know, not my first problem, but it was one of my problems, is if my project doesn't work in international frequency, it would be a problem because I don't have tools to regional frequencies. So one thing is that ZigBee, since the beginning, and it's written all over places, ZigBee bet on security. They say we don't want to commit the same errors from the past, and we want to use some kind of security to protect the communications. And they decided to use some cryptographic keys. We have the link key. It's used for unicast communication. Basically, it's a communication between 2 peers. It's shared by transport, pre-installation, or establishment. The only purpose of the link key is to encrypt the network key that is used for broadcast communication. Anyone who has the network key can communicate or can translate the ZigBee packets and understand what's going on there. As you imagine now, this is my purpose, break something here. The network is a key for broadcast communication, can be shared by transport or pre-installation. There is another key that is the master key. It's more, I don't know how many of you know Diffie-Hellman, but it's more or less like Diffie-Hellman. You have some variables, you exchange it, and you then derive with an algorithm the link key, then you encrypt the network key. Can be shared by transport, pre-installation, or user input. It's mandatory in one more recent standard of ZigBee Pro, but in my case, it wasn't mandatory, and it was fast to know that, but in my case, it wasn't. About key sharing, we talked a little bit before, but in transport, the keys are passed in clear at the time of the network access approval. The first contact between a plug, in my case a plug, and a router, the keys would be passed in clear, so I can get that key. The pre-installation comes pre-configured from factory, and the main problem is that if it's pre-configured from factory, if you want to change the key, it's more difficult because you need to go back to the factory to change it, at least for most of the mortals. And then you have establishment is the same as the master key, that allows two equipments to determine one key from a master key. About the tools, there are three main tools, let's say, but in this slide too, it's the RZ USB stick, RZ and Epimote. Both of them are for the same purpose. It's to translate the packets and to gather information from ZigBee. It's more or less like a Wi-Fi pan that you connect to your laptop. The main difference is between them is that RZ is older. You need to install yourself the firmware, and with the one from the right, with the GTech programmer. And you have then the Epimote that is newer, comes already with the firmware installed, which is great. But the great problem is that Epimote, you can't export it outside of the United States because it has some proprietary shit, and you can't receive it. So I used in the beginning this one. I will explain a little bit more later, but I used GTech to program it. And then there are some other tools. The KillerBee. KillerBee is a framework, is software to analyze ZigBee. And then you have GoodFet. For me, it's the most interesting one, especially because you need physical access to the devices. But you can extract the file system from the chips and from the plugs and devices. So my case study, as you understand, is some kind of plugs. I open the plugs and I have access to it, and I need to study everything, and I need to start doing something with it. During the first phase was studying all the vulnerabilities, all the tools. It took some time to understand the things, and what I would think that would be very, very easy. I'm not very good with it, but if I think, okay, I have the RZB USB stick, I need to solder some wires here to connect to GTech programmer. I don't know how to do it, I must be honest, but I thought someone can do it this very easily. So I decided, okay, I will try to find someone, and this is almost my reaction. I spent an entire weekend to find someone who can do it, because some people said, okay, this is easy, they tried it, the solder doesn't stick to the board, the wires are too small, I can do it. And I passed the whole weekend to find someone who can do it until I found one guy that did it, and I can start doing some work. And when I start doing my first problem, as I told you before, I want to grab some packets to understand if it works in regional or international frequency. And I use ZBee Stumbler. It's one of the scripts in ZBee KillerBee, and this gives me some information. Already giving some information, it's telling me, okay, this is international frequency, you can use it, and you can start doing some more interaction with it. It gives me an address. This address is volatile. When you disconnect the plug, when you connect it again, it's another one. You have extensible address, it's the MAC address, and you have the stack version. This is not what I have seen, it's always the same for everyone, so I don't believe this is real, so it is what it is. And it works on channel 11 from a bunch of channels like Wi-Fi. My other step was, okay, let's start gathering some other information from the plugs that I have, and I gather all the addresses from the plugs. The ZigBee router has this address, 4 zeros, and in every network, ZigBee network, the router is always for zeros, so we can identify every time the router. Then there is another tool. I must be honest, it wasn't very useful for me, but I think I might, it's good to show it to you. It's ZbFind. ZbFind is like a radar. You can grab your laptop with your board connected to the laptop, and you start walking through a warehouse or to a factory and see where are the sensors and grab them or do something with them. It's kind of useful. Then my next step was there aren't much more that I can do in information gathering phase, and I decided I need to start doing some packet analysis, and I start grabbing some packets. And this is more or less my reaction. When I start gathering the packets, I began looking at it and what's happening here? I couldn't understand because all the packets start freezing after 10 packets, 20 packets. I think the higher number that I got, it was 100 and something, which is not normal. And I can study it very well because it's very short. I can get 100 packets in 1 minute probably. So it was strange. My decision was try to talk with some people in the ZigBee community, understand what I was possible to do. No one knows about this error. I put some errors in their GitHub. They start some talkings and nothing can happen, and my time is passing. I don't really know what to do. I tried to contact one person that is the brain nowadays behind ZigBee. It's Ryan Spears. And I said, Ryan, I'm having this problem, please help me and sell me an app emote. And he told me it's impossible because I can't export it outside of United States. And I told, but why don't you come to Europe? I'll go there and fetch one of those bars. He told, it's impossible, I can't do it. And so one of my friends in New York bought one for him and lent me for a good time so I can study. I receive it and I put it plug it on my laptop. And my reaction, I was very, very happy because everything was already on the board with the new firmware, with everything set up, and my reaction was immediately this, because all the packets that I got as errors, and so I have one RGB USB stick that doesn't do anything. I have app emote that come with full of errors, and I don't have other options. What can I do now? I start contacting with Ryan, I start contacting with other people. Meanwhile, there was some guy that spent some time looking at the errors that I sent and found the error in the firmware core system and decided, okay, I need to correct this. He corrected, he sent it to me to do some beta testers in the firmware, and it was perfect, and I start doing the analysis. As I expected, the first packets were encrypted. I was expecting this. It was not a surprise. I confirmed it with by the way, this is ZbDump. ZbDump is the same as TCP dump, but for Wireshark, for ZigBee. And then we have zbwireshark. It's really the same thing as Wireshark with some add-ons, let's say, but you need to start it with zbwireshark. And I confirmed it that it was encrypted payload. And I can't do anything. I know what would be my way. I start doing some tests and trying to connect and disconnect the plugs, trying to reset the plugs, trying a bunch of things, and nothing happens on my logs. Everything was, there were no key. There is even a script, I don't remember the name, but there is a script in KillerBee that finds the keys automatically. If you gather, for example, I gather for an entire week of logs, I put it there, and he said, there is no key here. So the only option was to get some pre-installation key. So the key is already on the plug, comes from factory, it's in the file system of the plug, and this is my only option. So I went to GoodFet. It's that small board that I showed you. It's made by Travis Goodspeed. And what you need to do is solder 4 wires, one here, another here, and one in one of those, and connect to GoodFet on those pins, and then you connect to your laptop. I must say that it was very, very funny. Of course, it wasn't me who soldered again, but I asked some professional teams on Champalimaud Center that I knew between those times, and they did the job. They said, okay, I can do on switch. Do you remember the network layer? You have the switch on the right, but the others, I can't do it because you have a component above these pins and we don't have space. They did it, I was happy with it, I connected, but the board was burned. I couldn't have access to any information, it didn't connect. So at this moment I was more or less like this because I don't have nothing. If you believe, I'm doing master thesis and I don't have anything to show. I knew that this was a problem for me because I already asked the teacher that was orienting me, and if I don't have nothing, what will be the solution? And she told me, we'll arrange something and don't worry about. So I decided, okay, I need to relax. I need to sit down and think about this. I decided to sit on the floor of my living room, gather all the books, all the papers, everything that I have, and start reading again and again, everything to find if, after those months of studying, if I found anything new. And suddenly I found something in the standard that is this. They say a device will not intentionally or inadvertently transmit its king material to other devices unless the king material is protected. And as Schwarzenegger says, this is very cool because your king material should never go unprotected anywhere. The problem is that some paragraphs after this, you have this. A default global trust center link key must be supported by the device if no other link key is specified by the application. So, in one hand, you say that you can't share your keys and you can share your king material without protection. But the other hand, you say, if you don't have a link key defined by yourself, you have this one that you can use, and it's written on the standard. So I don't know what to say. So this one, it's written on the standard. The most amazing part is this one was signed by contract and no one can reveal it. And of course, someone revealed it on Twitter, as always. So this was strange for me. Why did they choose this method? It's very strange for me. And of course, I inserted on Wireshark this key, and I start and I get the network key. By the way, the way that I got the network key was resetting the plug, totally resetting, putting out of the network, come again, and the first time they connect, the router sends to the plug the key, the network key. I fetch the network key, I put it on Wireshark, in zbwireshark, and I can start reading all the information that's passing in the ZigBee network. And if you can see, remember that we are talking about plugs, you can see that the router sends an action to this plug to turn it on. Okay, this is nothing special, right? But how about if you studied the habits of that user? If I gather, for example, 1 week, 1 year, 10 years of the habits of a person, I can understand everything that she is doing and what are the habits and what will you do in the future, because there is a probabilistic that you'll do the same in the future. But we'll go there next. Then I start doing some other attacks, none of them which is, I did a distributed denial of service attack. I don't really know why. That's the strange part. After I put in the two keys, the network key and the link key, or the default link key, the network starts running very, very slowly. I didn't know why. I don't have two devices that can read and send packets at the same time, so I'm a little limited here. But what happens is that the network stuck, and for a while that didn't answer to the user, and I reset it again, I take off the board, and everything starts working again. Then I did some replay attacks with different frame counters, with the same frame counters, different frame counters, did some forging, trying to send different actions, but nothing happened. And this was the end of the study in ZigBee. But I had other areas that I can study. For example, I had the IP network and the website. I need to be honest, the website was already studied by a pen testing company. Of course, there weren't many things that I could get, especially because I was in a staging environment. So I found some errors, but they weren't available in production. So I didn't feel very well using my time for a thing that is not the production. So I let it go, and I decided to focus on my IP network. The first thing that I did was, of course, some Nmaps and some information gathering stuff, and I found that the ZigBee box, the ZigBee router, has the port 22 open. I tried to find what was happening there, the version of the SSH server that was there, and I didn't find anything interesting. So I moved on, and I decided to go to something that is called NTAP, is a man in the middle in a Raspberry, more or less. I connect the ZigBee router to the Raspberry. I connect the Raspberry to the IP router, and I start gathering all the information that passes there. And one thing that clearly got attention to me, it was that the first packet was this one. I got the basic stuff, and then I have some JSON file with push commands, remote SSH IP, remote SSH login, and remote SSH port. I tried to understand what's behind this, but once again, it was a production server. I didn't want to mess a lot with it. But you have the login, you have the port, you have the IP. The only thing is missing is the password, probably because it uses a key. But, well, you have some critical information passing in clear in your network. Okay, what I wasn't expecting, this is probably something that some of you expect to see, but what I wasn't expecting is that I can gather the same information that I got in the ZigBee network in the IP network in clear. When you send a command, an action through your phone, this action passes to the IP network and then goes to the ZigBee network and turn on or off the plug. The thing is, in this one, you have switched on the plug, and this is the address, the MAC address of the plug. And you know, once again, if you study it, you understand the habits of that person. In conclusion, I would like to talk about the past and the future of this work. I think the ZigBee community, it lacks a lot of maturity. Many of the tools doesn't work. There aren't too much information, too much documentation. It's very difficult to have something working. I would not say 100%, but I would say 80%. And I think there is a big gap from the point that you need to study this very, very well. I showed that it was possible to steal some keys. I truly believe, I showed that it was possible with the default link key, but I truly believe that if I had space to solder more wires in the plugs, I could do it with a good fat and physical extraction. Because if you think about the default link key comes already with the stuff, so you can gather from there. So for me, it's obvious. And then we come to the best part of it, is the capture of personal information. I did it in ZigBee network and IP network. And let's stop here for a while and understand the dangers of this. If you have this kind of information, most of you say, who cares if someone knows if I plugged in or plugged out something. Remember, this one was in clear, so you need to have physical access to it. But this one, I can be outside of your house and capturing all the packets because it's not necessary anything. And if we stop here, we start understanding that it's possible, for example, and I did this study, if you arrive at home at 5 p.m. And you watch television at 11, but for example, if you have an electric oven, I can understand that you cook between 8 and 8:30. And then you eat until 9, and at 11 you go to bed and you turn on your lamp and read until midnight. After that you go to bed, you sleep, and you wake up at 7 a.m. and you do your beer because your shaver is electrical, and you take your bath and you have a boiler that heats your water. And I understand all your habits. In the weekend you have other stuff. So for me this is very, very critical, because if you study someone, not for 1 day, not for 2 days, but if you study someone for 1 year, you can predict the future of that person. And this could be very critical. In terms of future work, I have three topics that I would love to study. Is the Silva and Nunes attack. It's two Portuguese that found that ZigBee have a problem with frame counter. If you rise the frame counter to the limit, the network stop. I couldn't do it. Sorry, I couldn't do it because I need two pens to do it, and I don't have it. I would love to do some packet forging in a way that I can change the infrared codes instead of connecting an air conditioner, for example, turning on a television or something like that, or something more dangerous. And he's already talking with the company to study PLC, one of the other plugs, because they didn't have the time to install it. I didn't have the time to study too. So we are doing this in the future. There are two additional contributions to this work. Honestly, in my point of view, and being humble, it wasn't very big, but they asked me to do some testings to the firmware to see if there were any problem after they corrected. I was with them doing that, and one thing that I found very funny is that they asked me the description of a new firmware installed using the GTEC programmer, because the ones that they use, it was a very, I would not say amateur, but something more poor. And this one is more professional, let's say like this. And they decided to put, I think it's already on GitHub of them, on the Killer Bee framework. So you can see what's this. But that's all. I think, hope you like it. If you have any questions, please do so.